everyone. Welcome to Calculus. Today we are starting a new chapter, and this chapter is going to be all about how to interpret derivatives. So in the previous unit, we have extensively studied the process for finding a derivative. And so let's just review a type of a derivative. Let's find one real fast. It says find f prime of x. So if f of x equals 3x to the third minus 4x plus 3, then f prime, if I apply the power rule, would be 9x squared minus 4. And then after we found derivatives last semester, we also evaluated them at a number. So if I were to find f prime of 1, that would mean I would take my derivative and I would replace the x with a 1 in the formula for a derivative. So 9 times 1 squared minus 4. And f prime of 1 would end up being 5. So these are two of the things we did last semester. We found derivatives, we evaluated them and got 5. And what does this 5 mean? Well, let's see. At x equals 1, there's a point on the graph right here. So what that means, if I were to take the graph f of x, the original function, the derivative evaluated at x equals 1 equals 5, means that at 1, if I were to sketch a tangent line, the slope of this tangent line would be 5. Now my sketch is a little bit off, but the slope of that line would be 5. This semester, we are going to see what it means in the context of a problem. So we're going to interpret that. So one thing that's going to help us is the idea of slope. And with slope, whenever you calculate slope, that slope formula is the difference of the y values, 1 divided by x2 minus x1. So we're going to remember the fact that to get the slope, we divide the y's by the x's, because part of what we're going to have to do today is we're going to figure out the units of the derivative and then interpret it in context. So we'll fill out a couple of blanks here. The derivative of function is the slope of the line tangent to f, or the original function, at a particular value of x. So that's what we did last semester. This semester we'll have some word problems, and when we interpret the derivative at a particular value as the slope of the tangent line to the given function at a particular point. When word problems are involved, we must keep the units in mind. So inches, square inches, inches per second, meters per second. We have to keep that in mind, otherwise our numbers are difficult to interpret. So one thing that's going to help us figure out those units is remembering that slope is the ratio of the y values divided by the x values. So let's look at this first example. During the time interval from 0 to 20, the population of deer in a forest can be modeled by the differential function z of t. So z of t is my function, and it shows me the population of deer in the forest. Now I'm not going to graph the function, but I am going to sketch some axes. So z of t is like where our y value would go, and t is where our x values would go. Now I need units. T is measured in weeks. It says that right here, t is measured in weeks. And it also says that the population of deer is the function, z of t. So z of t is population of deer. And so this unit would be a number of deer. And so that tells me that whenever I have a value of z of t, it's unit or it's measured in number of deer. So notice they give me this value at time t equals 7. There's 190 in the forest. Those are directly talking about z of t. So on the function at time t equals 7, way up here, that's off scale, but there's 190. So 7, 190 deer in the forest. But then they ask me to interpret z prime. Now to get z prime, I need to take my y units and divide it by my x units. So z prime is going to be measured in my y's divided by the x's. In other words, the number of deer per week. So this is how I get what the units of the derivative is. Units of the derivative. So then I've got to interpret z prime of 70 equals 90. So z prime of 7 equals 90 means that at time t equals 7 weeks, and then I go back up to this original statement, population of deer in a forest is, and then I have a positive 90, so since that rate of change is positive, I'll say it's increasing by a rate of 90 deer per week. And so my final answer to this problem is everything right here. So important things that we look for whenever we are working on interpreting a derivative, first of all, is the noun and the number. So I want to know the number, so the 90, and then the noun, the population of deer, so what's being measured. Then I want to know the units, so that would be the units of the derivative, the deer per week. And then I also need to know the time, so I need to know at time t equals 7 weeks. Now all of these will follow that similar format. You'll just notice the things that change. Deer per week changes. This is one thing that you'll have to figure out by thinking about y's divided by x's. And then the 7 and the 90 are going to be given to you, or you'll use a calculator to calculate those numbers. So let's try the next example. It says example 3, but it's really example 2. During the time from 0 to 14, the rate at which the amount of water in a tank is changing in gallons per minute. So the rate, that's not a, there we go. Gallons per minute can be modeled by the differentiable function f of t. So this time my function is going to be called capital F of t. And the unit of f of t is gallons per minute. And t is going to be my horizontal variable, or the independent variable. That's time, and its unit is also minutes. So if f prime, or f is measured in, I shouldn't do an equal sign, is measured in gallons per minute, this is gallons, then f prime is the ratio of the gallons per minute divided by minutes. So gallons per minute divided by minutes. And you might also see this as gallons per minute squared. And I shouldn't use equals because it's not equal to that. Those are just the units. So maybe I'll just do arrows or something. Okay, so now it's time to interpret f prime of 4 equals 35. So f prime of 4 equals 35 means that at minute 4, and then I go up here, look for these words, rate at which the water is changing, or amount of water is changing, and this time I have a positive rate, so I'll say it's increasing at a rate of 35 gallons per minute every minute or per minute squared. Now you can try example 3. I should tell you example 3 is T is time in days. And then you can check the notes in Canvas for the answer for that one. You'll have a lot. Basically, this is what you'll have to do. You'll have to figure out what the units are. So what are these units? You'll have to figure out how to interpret. And the other thing you'll have to figure out is sometimes they won't give you the G prime. Usually they've been saying, okay, well, G prime of 5 equals, and they'll fill in like 17 or something. And then they'll say, just interpret that. Well, sometimes you actually have to find that number. And yes, I can find G prime, a formula for G prime, by taking the derivative of this expression, or I can use my calculator to help me do this. Let's pause this for a second. So one way I can evaluate the derivative is to use Desmos. And if you use Desmos to do this, then G of t, the first thing you'll need to do is type in the formula that they gave you, and it's really important that you define it the same way that it's been defined. So G of t equals 90 plus 45 cosine of t squared over 18. So type in the formula the same way that it looks. Then I need to find G prime of 5. So what this is going to do is it will evaluate G prime of 5. And I'm using an apostrophe to type in the prime part. And this number is the value of G prime of 5. So I'll have to round it to 3 decimal places. So it looks like it's negative 24.588. So I can say that G prime of 5, and I'm rounding, so I'll use a squiggle equal sign, is approximately negative, I forgot it already, negative 24.588. And then I have to do units. So it tells me the rate in tons per hour. So that is the unit for G of t. And t is measured in hours. So that's the unit of t. So if I think about the y values, tons per hour, an hour, if I divide those two, it would be tons per hour every hour. Then it says to interpret my answer in context of the problem. So I would say at hour, t equals 5, and then I just go here, copy this, rate at which gravel arrives is, and I see I have a negative, so I say decreasing at a rate of 24.588 tons per hour per hour. All right. So those are the things that you'll have to do today. So you'll have to, number one, be able to figure out what unit the derivative is going to be written in. Number two, interpret the derivative. And number three, use your calculator to evaluate the derivative. Hope this lesson goes well for you. If you have any questions, please let me know.